Hello guys, welcome to Algorithms Made Easy. Today we will go through the day 6 problem from August LeetCoding challenge. Find all duplicates in an array. Please like the video, and if you are new, don't forget to subscribe to our channel so that you never miss any update. Given an array of integers where n is the size of the array, some elements appear twice and other appear once. Find all the elements that appear twice in this array. Let's leave the follow-up question for now and we will come back to it later. In the example, we can see 2 and 3 are repeated, so the output contains these numbers. We will discuss 4 approaches starting with the basic one while optimizing the solution a level up in each method. The first one is the brute force approach, wherein we will just focus on finding a solution and keeping the complexity part aside. So we will be iterating over the elements of the input array and simply look for any other occurrence of the current element in the rest of the array. The comparisons will look like this. While we are at the first element, we'll compare its value with all the other values appearing after this value in this array. Similarly for the second element. As we are comparing values with all the other values, we will have a nested loop and the complexity will become O of n square, while the space complexity is O of 1 as we are not using any extra space. Here is a code snippet for the approach. To get rid of the nested loop, we can use sorting. This brings us to the second approach, sort and compare adjacent element. Let's take this example and sort it. After sorting, the values that are equal will be adjacent to each other. So when we use a single loop and check the adjacent value for equality instead of checking the entire array. Here 2 and 3 are repeated, which is our result. Summarizing the steps, we first sort the array and then loop over it. While looping, we check if the adjacent values are equal. If yes, we add them into the result list. At the end, we just return the result. As this method involves sorting, the time complexity becomes O of n log n, and while the space complexity is still the same. Here is the code snippet for this approach. Now, to eliminate sorting, we can either use a data structure that tells us if the element is duplicate like set, or we can store the count of the values in a data structure and use it to give the result like map or array. This will use extra space. Let's see this using a set. So we will take a set and a result list. We will iterate over the array and keep adding the element in set if not already present, and if present, we will add it in the result list as it is a duplicate. Starting with 4, as it is not present in set, we add it. Similarly for others. For 2, we can see that it is already present in the set, so we add it in the result list, and similarly for 3. At the end, we return the result list. Summing it up, we initialize a set and start looping over the array. If the current value is already in set, we add it in the result list, otherwise we add it in the set. At the end, we return the result list. The average time complexity here is O of n, while it goes up to O of n square in the worst case, as the lookup in hash set can degrade to O of n. To improve this, we can use a tree-based set that will have a worst case lookup time as log n. The space complexity is O of n. Here is the code snippet for this approach. All the methods that we have seen until now either use an extra space or have a time complexity higher than O of n. The question arises that can we achieve it without using an extra space and in O of n runtime? The answer is yes. We can mark the element visited in the input array itself. This gets us to the fourth method. There is a key information that we did not consider till now. The integer in the input array satisfies 1 to n, where n is the size of the array. With this, we can deduce two insights. First being that all the integers present in the array are positive. That is, the value will always be greater than 0 for any valid index I. And secondly, the decrement of any integer present in the array must be an accessible index in the array. That is, for any integer x in the array, x minus 1 is the valid index, and thus array of x minus 1 is a valid reference to the element in the array. With this new information, we can iterate over the array, and for every element x in the array, we can negate the value at the index of absolute x minus 1. The negation operation effectively marks the value as seen or visited. For 0th index, the value is 4, and thus if we mark the index 4 minus 1, that is 3, visited by negating its value. Moving to index 1, we mark the index 2 as visited by negating it. We repeat it for the entire array. At the end, we get this updated array. Now that we have updated the array, we iterate over it once again, and for every element x in the array, if the value at the index absolute of x minus 1 is positive, we can say that it must have been negated twice. Thus, absolute x must have appeared twice in the array, so we add absolute x in the result. In the above case, when we reach the second occurrence of absolute x, we need to avoid fulfilling this condition again. So we will again negate the value at index absolute x minus 1. Starting with index 0, we can see that the value at index 3 is negative. So as per our previous deduction, we can say that it must have been appeared once. So we move ahead. Now for index 1, we see that the value at index 2 is positive, which means it has appeared twice. So we add 3 in the result and negate this value so that the second time when we encounter it, we do not end up adding it in the result list twice. Same for this one. We do this for all the elements in the array. At the end, we return result list. Now the question is, can we do it in single loop? Remember the first loop in our previous approach. What if we get the result in that very loop? In that loop, values which are duplicates were positive at the end. So we can say if we encounter a value which is negative, then we are sure that we have seen that value twice. That becomes our condition on which we will add the number into the result. Let's start with the loop. Like before, we will use the value at the index absolute of x minus 1. Now, if the value is not less than 0, we move ahead. And like before, we will simply negate this value. We will do the same for 3 as well. We will continue doing it. Now we encounter a number for which the value at the absolute of number minus 1 is negative. It means that we have already seen this value, so we add it into the list and as usual negate it. Same will happen with the minus 3. At the end we return result. The algorithm is quite similar to previous approach. We will iterate over the array and for every element x, we will check if the value at the index of absolute of x minus 1 is less than 0. If it is, then we add the element x into the result. We will always negate the value at the index. The time complexity is O of n while the space complexity is O of 1. Here is the code snippet for both 1-pass and 2-pass solution. Link to GitHub for codes is in description below. Thanks for watching the video. If you like the video, please like, share and subscribe to the channel. Let me know in the comment section what you think about the video.